Hi everybody, today we are going to be starting Unit 4. Before we get started, please don't forget to do the attendance quiz and the lesson check. And also please know that any missing unit tests are going to appear as a 0 in the gradebook until it's completed. So if you haven't done the last unit test, you want to make sure you put that on your to-do list and don't forget to complete it. And you have to submit it to get the credit. Just clicking on it doesn't count. You have to submit it to get the credit for it. So for this unit, you are going to want a scientific calculator. If you have a handheld calculator, that's great. If you don't, I highly recommend using Desmos. Desmos is a calculator that's available on the SOL, so getting to know how to use it is very good. We're going to be using the square root button a lot, and we're going to be using these trig functions a little bit too. So you want to make sure that you have a calculator that has a square root function on it, and you see a sine, cosine, and tangent button, and we'll learn how to use those. We are going to talk about the Pythagorean theorem, and the Pythagorean theorem is something that I know they teach in like middle school, maybe even Algebra 1, but just a little review. Okay, the Pythagorean theorem is used to find a missing side, and it has to be a right triangle. Okay, you have to have a right triangle to use the Pythagorean theorem. We call the short sides A and B, or legs, and the long side is the hypotenuse. Hopefully this feels familiar. Okay, so over in my picture here, A is a leg, B is a leg, and C is the hypotenuse. I'm going to change the equation that you probably have memorized, and I'm going to have it say C squared equals A squared plus B squared. And if you have A squared plus B squared equals C squared memorized, that's fine. I just switched the left and right side, and you'll see why in just a moment. Okay, so let's practice using the Pythagorean theorem with some examples. So my first example, I have a right triangle. The short leg is 8, the long leg is 13, and the hypotenuse is x. So in our equation, C is always the hypotenuse. And if it helps you to come over here and label this A, B, C, you are welcome to do that. C is x, so this becomes x squared. A is 8, so this is 8 squared. And B is 13. So in our calculator, we'll type 8 squared and 13 squared. And if you want to do this all in one step, you're welcome to do that. So I could type 8 squared plus 13 squared. So we got 233. We are almost there. We have to get rid of a square. Remember, to undo a square, we square root. A square root and a square cancel each other out. Once I do that, I'm left with just x on the left side, and we'll find the square root of 233. The directions say to round our answer to the nearest tenth, so we can just use the calculator to find the square root and round to the nearest tenth. So what we'll do there, square root 233. It's about 15.3. Because the number following the 2 is bigger than 5, I'll round that 2 up to a 3. 15.3. And I'm going to use a little squiggly equal sign. The squiggly equal sign, remember, means approximately. So this means I rounded it. There are no units in my picture, so my answer doesn't have any units. But if there had been units here, inches or centimeters, then my answer would also have units. I'd like you to try number 2. Try number 2 now. So for number 2, you should have gotten x is approximately 34.8. If you need to double check your work, you're welcome to pause the video and double check and make sure that you get the right answer. If you have any questions, Maybe put a star next to this one and remember to bring it to office hours. Now what happens if our missing side is not the hypotenuse? We're still going to use the Pythagorean theorem. And we're still going to say, okay, the short leg is A, the long leg is B, and the hypotenuse is C. So when we fill in our equation, C is 9, A is X, and B is 7. So now we need to solve for X. 9 squared is 81. 7 squared is 49. And I need to get X squared by itself. So we're going to subtract 49 from both sides. 81 minus 49 is 32. So now I have X squared equals 32. I need to get rid of the square because I just want to know what X is. So we'll square root both sides. And I'll say, hey, calculator, what's the square root of 32? It's about 5.7. And my answer makes sense for my picture because X was the short leg and 5.7 is shorter than 7. Number 4 is a very similar problem. You're given one leg and the hypotenuse. You need to find the missing leg. Try that one now. So for X, you should have gotten about 23.8. When you square your hypotenuse and your leg, notice I didn't round it. I didn't say 930. I didn't say 930.3. I kept the entire thing that was on the calculator screen. So you want to do that too. You really don't want to round anything until the very last step, because the more you round in these steps, the more inaccurate our answer is going to be each step further. So round at the very last step. One question you might be asking is, how do I know which one's the hypotenuse if this one's missing? How do I know this one's not the longest? Remember, your hypotenuse is always across from the right angle. So the side across from the right angle will always be the hypotenuse. On the next slide, we have a nice fun problem here. We have two right triangles in our picture, and I know they're both right triangles because if this one's 90, well then so is this one. We're going to find the length of X. So what I'm going to do is I'm going to redraw each of those right triangles. So here's the one on the left. I know its height is 12 and its hypotenuse is 14. And then the one on the right side, I know its hypotenuse is 29 and its height is also 12. So X, what we're going to do is we're going to find this piece and add them together. And we can give them variable names. I called them A and B on my key. Probably not the smartest idea for our Pythagorean theorem. Let's see, I'm going to call them M and N here. So X is going to be the sum of M and N together. So this will be M and this will be N. So X will be the length of this whole thing, and we'll use the segment addition postulate for that. So we're going to do the Pythagorean theorem 2 times. For the first one, our hypotenuse is 14, our leg is 12, and other leg is M. 14 squared is 196, 12 squared is 144. I'm going to subtract 144 from both sides to get M squared by itself. So M squared is 52. To get rid of a square, I square root. So M is approximately 7.2. Over here for N, the hypotenuse is 29, a leg is 12, and the other leg is N. 29 squared is 841, 12 squared is 144. Subtract 144 from both sides. We get 679 equals N squared. And we'll take the square root of both sides. So N is approximately 26.4. So to find X, I'm going to take the length of my M and the length of N and add them together. So here X is about 33.6. You may have been tempted to say, oh, this big triangle is a right triangle and just use 14 and 29 as legs and X is the hypotenuse. You want to be very careful with that. That won't always be true. So instead, we can just break this apart into two smaller right triangles and know for sure the length of those pieces and add them together to get x. Okay. So now here comes the reason why I gave the Pythagorean theorem to you as c squared equals. Okay. Because we know different types of triangles. The first one we've been talking about is a right triangle. So if c squared equals a squared plus b squared, then you know you have a right triangle. What if c squared is greater than a squared plus b squared? If that happens, you have an obtuse triangle. And if c squared is less than a squared plus b squared, then you have an acute triangle. So I like to remember it this way because I know that obtuse means greater than 90. So if I see a greater than symbol, I know it's obtuse. I know acute means less than 90. So if I see a less than symbol, then I know that I have an acute triangle. So if you keep that c squared on the left, that can definitely help prevent any confusion between your obtuse and your acute triangles. Okay. So let's look at some examples here. First, you always want to make sure that the triangle exists because they are going to try to trick you and give you three numbers here. And if the triangle doesn't exist, you're not going to realize it and you're going to pick the wrong answer. So always double check to make sure the triangle exists. Remember, the triangle exists when the small side plus the medium side is greater than the large side. So just check that step first. 3 and 7 are my small and my medium. 10 is greater than 9. So this triangle does exist. So I know that it not a triangle is not even an option. So this is either acute, right, or obtuse. Always make A the small, B the medium, and C the longest. So what I'm going to do here is we're going to use our Pythagorean theorem, but I don't know what symbol is going to go here yet. So I'm just going to leave it blank, and I leave this little box to give it a space. C is 9, A is 3, and B is 7. So 81. And then you're welcome to do these separately. 3 squared, 7 squared, add them together. Or if you just want to put them all in the calculator in one step, that's fine too. Whatever works best for you. 3 squared plus 7 squared equals 58. So now I have an 81 and a 58, and I can determine what symbol would go in that box. 81 is greater than 58, so it's a greater than symbol. And because I kept c squared on the left the whole time, I know that greater than will correspond to obtuse. So these three sides could be the lengths of an obtuse triangle. Okay. Let's do number 2. First, we always want to check, does this triangle exist? Here's our small, medium, large. So is 20 plus 21 greater than 29? Clearly this one is, but it's always good to check. Okay, so this one is a triangle. And now we will use our Pythagorean theorem. Here's A, here's B, here's C. 29 squared is something to 20 squared plus 21 squared. 29 squared is 841. 20 squared plus 21 squared, you can enter that in a calculator. It's also 841. So now we know which symbol to put in between. Is it a greater than, a less than, or an equal? Well, of course, it's equal. These are the same number. So that corresponds to a right triangle. Okay. And now let's look at number 3. We want to test to make sure that this triangle exists. So add your small and your medium. Make sure they're greater than the large. Uh-oh. 15 is not greater than 16. That's not true. So this isn't even a triangle. And I can stop right there. If I didn't test that step, I would keep going, and then I would pick the wrong answer over here. So just be very careful. You want to make sure the triangle exists before moving on to the next step. I'd like you to try number 4. Try number 4 now. Okay, so you should have gotten 484 is less than 578 because I have a less than symbol that tells me this triangle is an acute triangle. All right, so that's using the Pythagorean theorem and using it to identify either acute, right, or obtuse. We're also going to talk about some beginnings of trigonometry. Okay, so first, what is trigonometry? Well, trigonometry is the study of triangle measurement. We have three trig ratios that we're going to cover in our class. The first one is sine, and sine is usually abbreviated SIN, although you still say it's sine. Cosine is abbreviated COS. We still say it cosine though. And tangent is usually abbreviated TAN. And of course, we'll still say tangent when we see that word. And each of these functions has a different ratio. So the sine function is the ratio of the leg opposite the angle to the hypotenuse. Okay. So what I like to remember here is the opposite over the hypotenuse. So if I'm looking at angle A, here it is. We know that C is the hypotenuse. The side opposite angle A is lowercase a, and the side adjacent or next to angle A is B. So for the sine of A, and this will always be the angle right here, we will say this is a lowercase a over h. Now what if the angle changes? Well, if the angle changes, I'll use a different color, then the opposite and the adjacent are going to have to flip-flop because opposite angle B is lowercase b, and adjacent to angle B is lowercase a. So for the sine of B, sine is opposite, so this opposite angle B is lowercase b over the hypotenuse. Oh, I should have made that a C, not an H. That's silly. Okay. Cosine, very similar idea, but it's the ratio of the adjacent to the hypotenuse. So if I'm looking at angle A, the leg that is adjacent to angle A is lowercase b, and the hypotenuse in this triangle hasn't changed, it's still C. The cosine of angle B is the adjacent side, so that's lowercase a over the hypotenuse. Tangent is the ratio of the leg opposite the angle to the leg adjacent to the angle. So for the tangent of A, here's angle A, we want opposite over adjacent. So A over B. And for the tangent of B, we would want opposite over adjacent, B over A. Okay, that's a lot to remember. So here's a shortcut or a trick to remembering these rules. The sine of an angle is always the opposite over the hypotenuse. And so we might remember SOH. Cosine is the adjacent over the hypotenuse. So you might remember that as CAH. And the tangent is the opposite over the adjacent, and we can remember that as TOA. So if you've ever heard a mathematician say SOHCAHTOA, they're referring to the trig ratios. I have had students write this a little differently, and I really like it, so I'm going to show it to you. They like to sometimes write it like this. SOHCAHTOA. So they remember it SOHCAHTOA still, but when they write it this way, it sets up the ratio for them. And once you know those ratios, all of these problems become extra easy. So let's practice it. I am going to write SOHCAHTOA up here at the top so we can use it. I recommend you do the same. Okay. So here it's asking us about angle A and angle C. It will always be an acute angle here with our sine, cosine, and tangent. They will never ask us for the sine, cosine, tangent of a right angle. That wouldn't make any sense. So this will always be the acute angle. Okay. So let's work with angle A first. We'll do that in, how about, okay. So here's how I like to solve a problem like this. The first thing I do is I put an arc on the angle I'm talking about. So we're talking about angle A. So come over here and put an arc on the angle A. Then I label my sides either O, H, or A. H is always the hypotenuse, always the longest side. O is the side opposite angle A. So opposite or across a triangle, I put an O there. And adjacent is the leg that is touching the acute angle. So here's my adjacent. Now I know what numbers for my O, my H, and my A, and I can plug them in. So the sine of A, sine is opposite over hypotenuse. So this will be 5 over 13. That's it. If the fraction can be reduced, you would reduce it, but this one doesn't, so I'm done. Cosine of A, cosine is adjacent over hypotenuse. Adjacent is 12, hypotenuse is 13. There it is. Tangent of A, tangent is opposite over adjacent. Opposite is 5, adjacent is 12. And that's all we would need to do for this. If these could be reduced, we would reduce the fraction. Since they can't be reduced, we leave them just how they are. Let's practice it for angle C. Okay. So this time, we're going to put an arc on angle C. If you need to erase or scratch out how you labeled the first time, that's fine. Because our O and our A's are going to change. The O is opposite C this time. So now 12 is O and 5 is adjacent. 13 is still hypotenuse. It's still the longest side. So the sine of C is opposite over hypotenuse. The cosine of C is adjacent over hypotenuse. And the tangent of C is opposite over adjacent. Okay. If you are missing a hypotenuse, notice in number 2, our hypotenuse is missing. Then you'll have to use a method to find that missing hypotenuse. Remember Pythagorean theorem. So C squared will equal 9 squared plus 12 squared. So C squared is 225. Take the square root of both sides. Oh, this is pretty, 15. So now I know that this hypotenuse is 15. Now I have everything I need to fill in my ratios. Try it. It's okay if you get it wrong. Just try it. Put an arc on the angle that you're talking about. Label the O, the A, and the H. And use our SOHCAHTOA to fill in the ratios. Try that now. Okay, so these ones you actually did have to reduce the fraction. When you were talking about angle W, 12 was your opposite and 9 was your adjacent and 15 was your hypotenuse. So if you got 12 over 15 for the sine of W, that's great, but don't forget to reduce that fraction. 12 over 15 reduces to 4/5. Cosine of W is adjacent over hypotenuse, so 9 over 15, and reduce the fraction to 3/5. Tangent of W is opposite over adjacent, so 12 over 9, which reduces to 4/3. Then when you switched over to looking at angle X, your O and your A had to switch. So here's angle X, which means that O is 9 and A is 12. So the sine of X would be 9 over 15, which reduces to 3/5. The cosine of X is 12 over 15, which reduces to 4/5. And the tangent of X, 9 over 12, which reduces to 3/4. we can use these to solve for missing sides. Now, the reason we can't use Pythagorean theorem here is because I only know one side and not two. If I knew 19 and this leg, then I could just use Pythagorean theorem to find x. But since I don't know this leg, I need another method. And we're going to use our trig to do that. So what you're going to do, and if you do this the same steps every time, it should feel quite simple after you practice it a few times. We're going to use SOHCAHTOA. And we're going to set up an equation. Always put an arc on the acute angle that you're given. So in this case, 28 degrees. I'm going to put an arc on it. Then label the sides that are given to you, either O, A, or H. So 19 is the longest, it's the hypotenuse, so I label that H. And X is opposite that 28, so that's O. Because there's nothing down here, I'm not going to label that anything. I know it's the adjacent, but I'm not going to label it because it's not there. So in my picture, I have an O and an H. So I go to my SOHCAHTOA and I figure out, okay, which one uses O and H? S. S stands for sine. So we'll set up our equation. The sine of the acute angle, always the angle in here. So I'm going to put a 28 equals the opposite. Well, opposite is X over hypotenuse. Now we have an equation we can solve. I want to solve for X. Right now it's being divided by 19. I like to think of cross multiplying here. I can always put a 1 in the denominator. The sine of 28 is a number. It's a super ugly number, but it's still a number. And so I can put a 1 in the denominator, and now I can cross multiply. X times 1 is X, and 19 times the sine of 28 is 19 times the sine of 28. Be careful how you write this. Okay, this is not sine of 28 times 19. That would not give you the correct answer. You're taking that sine of 28, whatever ugly number that is, and multiplying it by 19. So just be very careful with that. I have a note up here that says to make sure your calculator is in degree mode. That is very important. No matter what calculator you're using, you have to be in degree mode. Otherwise, you're going to get the wrong answer even if you do every step correctly. So here's how we put Desmos into degree mode. On your Desmos screen, you'll see this button here. See, it says DEG. If you click it, now it's in radian mode. We don't want radian mode. We want degree mode. If you're using a handheld calculator, you'll want to Google or email a teacher, maybe me if I'm not out maternity leave already, and ask, how do I put my calculator in degree mode if you can't figure it out? Because if your calculator is not in degree mode, you're going to get the wrong answer every time. So degree mode, very important. Put a big star next to that. We are multiplying 19 times the sine of 28. So that's exactly how I type it in the calculator. 19 times the sine. Notice when I click sine, it immediately opens these parentheses. You always want to put your angle in those parentheses. So 8.9. So X is about 8.9. Simple as that. Let's do another example. All right, so step 1, put an arc on the acute angle you're given. Here it is. Label the sides that you're given, either O, A, or H, depending what they are. So across the triangle there is opposite. This would be my hypotenuse. There's nothing there, so I'm not going to label it. And 32 would be my adjacent. So I have an O and an H. So looking at SOHCAHTOA, I'm looking for the one that has an O and an A. Oh, that's T. T stands for tangent. So this will be the tangent. Remember, the angle will go in these parentheses. So 41 equals the opposite over the adjacent. So now we're going to put a 1 down here and cross multiply. If you have a different method to solve for X after this and it works, that's fine. But X times 1 is X. 32 times the tangent of 41. The tangent of 41 is a number. Super ugly, but it's still a number. Make sure that looks like a 4. And this is what we'll type into our calculator. So I will type 32 tangent 41. So we get about 27.8. Okay, I would like you to try number 3. Try number 3. Follow the steps. Put an arc on your angle, label your O, your A, your H, whatever you're given. Set up your equation, cross multiply, and use your calculator to find an answer to the nearest tenth. Try that now. Okay, so for number 3, you should have gotten x is about 24.3. You should have used cosine. Our angle was 21 degrees. 26 was the hypotenuse, and x was an adjacent. Cosine is the function that uses adjacent and hypotenuse. So the cosine of 21 equals x over 26. Put a 1 down in the denominator and cross multiply. When you cross multiply, you get x equals 26 cosine of 21. Put that in your calculator, making sure you're in degree mode, and you get 24.3. All right, last one here on this page, try number 4. Follow the steps, try number 4. Okay, so you should have gotten x is about 11.4. You should be using the tangent function here. Our angle is 55 degrees. X is across the triangle from that or opposite it, so x is the opposite, and 8 is the adjacent. The function that uses opposite and adjacent is tangent. So we'll say tangent of 55 equals x over 8. Cross multiply. In our calculator, we would type 8 tangent 55, and we get about 11.4. We might see problems like this with word problems. So here's an example of a word problem with this. Jake leaned a 12-foot ladder against his house. If the angle formed by the ladder and the ground is 68 degrees, how far from the base of the house did he place the ladder? I highly recommend drawing a picture. You don't have to be a good artist. You're going to see that I am clearly not a good artist, but good enough for the problem. So here's the house. He leans a 12-foot ladder against the house. Here's his ladder. Here's the ground. So the ladder is 12 feet long. If the angle formed by the ladder and the ground is 68, so here's the ladder, here's the ground, so this angle is 68 degrees. This is a right triangle now. How far from the base of the house did he place the ladder? Here's the base of the house, here's the ladder. We're looking for this length. So if we were looking at just a right triangle, we would see that the hypotenuse is 12 feet. This angle is 68, and we are looking for this length. Now we have everything we need to use trigonometry to solve for x. Put an arc on our angle. 12 is the hypotenuse. X is the adjacent. So I know I'm going to use cosine. Cosine of the angle equals the adjacent over the hypotenuse. Cross multiply. Type this in our calculator. It's about 4.5, and now we have units. There's a 12-foot ladder. So our units are feet. So he placed the ladder about 4.5 feet from the base of the house. Okay, I'd like you to try drawing the picture for this one. Just try drawing it, and then we will do it together. So go ahead and draw this picture. Okay, so clearly you do not have to be a good artist here. What I have is I have like my door of my airplane. It says the door of the plane is 7 feet from the ground. So from here to here is 7. The angle formed by the end of the ramp, so here's my ramp. Here's the end of the ramp, and the ground is 25 degrees. How long is the ramp? So the ramp is my unknown, so I give that x. So if I'm looking for the right triangle, I see x here, 25 here. I know it's a right triangle, and this height is 7. So now we're going to follow our process. Put an arc on your angle. Label X is my hypotenuse, 7 is opposite. So looking at SOHCAHTOA, I want to know which one uses O and H, and that's the S, that stands for sine. So the sine of our angle equals the opposite over the hypotenuse. This is a little different than the examples we've seen because X is in the denominator. Cross multiplying is still going to be our friend. Okay. This time I get 7 times 1 and X times the sine of 25. The sine of 25 is a number. This entire thing is a number. Super ugly number. You can type it in your calculator. Don't round that number. What I'm going to do is I'm going to divide both sides by the sine of 25. So what's going to happen is over here, the sine of 25 will cancel, leaving me with just X. And then over here, I'm going to do 7 divided by the sine of 25. So I'm going to type that in my calculator. So instead of multiplying, I'm going to divide 7 divided by the sine of 25. It's about 16.6. So the length of that ramp is about 16.6 feet. So if you happen to get your variable in the denominator here, that is okay. You're just going to have an additional step after you cross multiply. Okay, so that was 4.2. We are also covering 4.3 today. Oh, that was 4.3 also. So this was 4.2 and 4.3 together. Okay, so now you need the attendance word. Let's see. Here we go. Your attendance word is ratio. A trig ratio will always be written as a simplified ratio or a fraction. Ratio is your word. If you would like extra practice with right triangles, I do highly recommend doing the OMHS material, and you are welcome to email for extra practice and get extra practice that way. There will also be office hours and small group to help you with that also. Have a great day, everybody.